Okay, everybody, how you all doing? We're going to go into take a little bit of a different path here, and we're going to talk about since we've talked about elements and compounds. What I'd like to do is just talk a little more about formulas and how to write formulas. And there's really two parts to this. There's finding the name of a formula, and there's also finding the formula or the written symbol formula. So first of all, let's talk about what formula writing is and how to count atoms and see what formulas look like. Okay. So first of all, we want to learn how to count atoms and molecules and be able to count them and be able to see how they are as far as numbers go. So, what is a chemical formula in the first place? It simply shows the number and type of each element. So that's really what you want to get through with the formulas. The first part of it, really. Okay. Second part is if we take a look at the formula of an element, it's actually kind of simple. Can go through this pretty quickly. The symbol pretty much shows the element, right? So your symbols here, maybe iron would be here, and then you have copper and iodine and xenon, and the first letter, of course, is going to be the capital letter of each element. Okay. You can also have multiple atom elements that are composed of more than one particle. So with the single elements here, you'll see you can represent those as a single atom, where S8, O3, and P4 are collections of particles. So an S8 would be a collection of 8 particles of sulfur. Oxygen would be 3 particles of oxygen. And P4 might look something like this, where you would have, 4 P's together in a little bond there. Okay, that would be a little P4. Okay. The subscript down here will tell you the number of atoms that are present. And typically, the number of atoms that are present will be bonded to each other if it's a subscript. So it's important to know about elements. Okay, as far as compounds go, it gets a little more complicated because in a compound, you're going to have, remember, in a compound, you're going to have different elements, right? So since your elements are going to be different, you're going to have a little more of a complicated formula. Okay, so there's two main types. There's binary compounds, which are going to be composed of 2 different elements because of the word binary. Okay, so 2 different elements. Okay, and ternary compounds, well, you probably guessed that. That would be 3 different elements. Okay, so again, the key is different elements because if you were bonded to the same element, you'd still be an element, right? Okay. All right, so if you were to label binary ternary here, I guess you could pause the video. I'll give you a second to pause it, and you can label those. Okay, so if we wanted to go back and try this ourselves, we can say, okay, well, binary, this would be 2 elements. H2SO4 would have 3 elements, so that would be ternary. Okay, carbon dioxide would only have 2 elements, which would be binary. This would be binary again, and again, you guessed it, ternary. Okay, don't worry about the subscript here. You're looking to see, do you have 2 different elements or do you have 3? That's the key. All right. Just to take a look at what the subscript versus a number in front looks. When you see a subscript, just keep in mind that you're going to have a bond between these 2 atoms when you have that subscript down here. So it means that there's 2 bromines, but you're going to have a chemical bond in that between the 2 atoms, which is your chemical bond, which would be written as a little bar here that tells you that they're bonded together. Whereas if you have 2Br, you still have the same 2Br, but you're not going to have a bond. Okay, and you'll see that there's no bond in between the 2 of them. There would be 2 separate Brs. So Br and Br, although there's 2, the arrangement is different, and you really have to understand that. You really have to be able to visualize that as you go. So I think it takes a little time. Okay, so here's a picture of an O3 molecule. Okay, so if I go back to my pen color here, let's change that to black. All right, here's your O3 molecule, which is a group of O3. And then if I have 2 O3s, that means I would have 2 times O3. So here's the first O3, and here's the second O3. Again, these would not be bonded, as you can see. Okay. All right. Some compounds that you want to know here is some ones you want to know. Is ammonia is one you want to know. Okay, NH3 is something you want to be able to remember what that is. Methane, CH4, you want to be able to remember. Okay, Glucose is really important, C6H12O6, as I think you guys know already. Okay, ethanol, C2H5OH is an important compound to know, and methanol you want to know also. Okay, so methanol is a simple alcohol, okay, where ethanol down here is that's your that's the alcohol is in alcoholic beverages or ones that are in actually in hand sanitizer, believe it or not. So that's important to know also. So that would be um, hand sanitizer. Okay. All right. So that takes care of that. So the next one. All right. So what we want to do here, when you count atoms and molecules, okay, is knowing what the numbers mean. Okay. So if you ever see a coefficient, okay, if you see a coefficient that's in between the two, then you have. Um, pen here, sorry. So little pen problem here. Okay, there we go. All right. So if your coefficient in front of a formula, then that's going to be a multiplier for the entire formula. Okay. So if you have, so for example, say you have 4 CO2. Well, we know we have a CO2 molecule or group. If you have a 4 in front of that, that simply means that you have 4 groups of CO2. You have a CO2, a CO2, and a CO2, and a CO2. So if you're looking at groups of CO2, you would have 4 of them. But it also means that this 4 is also 4 Cs, and you also have 4 O2s present at the same time, don't you? I mean, you have 4 Cs you can see here, but you also have 2, 4, 6, 8 Os. Okay, so you can, by looking at this really quickly, you can see that you also have 4 Cs and you have 8 Os because it's 4 times the O2. All right, and that's what you would look like. So a single CO2 would look like that. Okay, so just remember, if you have a coefficient, this coefficient is simply a multiplier not only for the entire thing, but it's also a multiplier for the C's, and it's a multiplier for the O, where if you have a subscript, that only goes for the O. Okay, so that's really important to know. And we don't write ones, so you wouldn't see a 1 on the C. Okay? All right, so let's just say I'm given the formula of C3, C6H12O6. All right, and I want to figure out, I want to ask the question, well, how many carbon atoms do I have here? Well, if I look at this, I'll see that I have 6 carbon atoms, okay, 6 of them, but there's a multiplier in front by 3. So the 3 would be multiplied by the 6, and I would have 18 carbon atoms. All right, so remember, this 3 is going to go for each of these elements. Okay, how many hydrogens? Well, I have 3 hydrogen atoms here, or 12 hydrogen atoms, and then I'm going to multiply that by 3, so I'll end up with 36, 3 times the 12. All right, if I ask how many oxygen atoms, I would have 6 oxygen atoms because the 6 goes with the O, but then I would multiply that by 3, and I would also have 18, which would match the carbon. If you ask me how many glucose molecules, well, that's kind of interesting because glucose is actually this entire molecule. So if I'm talking about this entire molecule, I would have 3 times that entire molecule. All right. How about how many total atoms? Okay, I could ask you that too. So you would have to add up 3 times the 18, 3 times the 12, and 3 times the 18 together, and all together you would have 72. So what's the point really? The point is really, it depends on what they're asking for, and also look at the different ways that you can, analyze what actually is in a formula, according to also how many molecules you have. So again, atom versus molecule. Remember, molecules is your group. Really important that you understand how that works. Okay, so just a little exercise. Let's just go through this and, take a little bit of practice. So let's just say we had parentheses. Well, parentheses are interesting because remember, I mean, if I look at the top here, parentheses, what do? They make things into groups, right? So if you had x plus 2, and you had, if you had x plus 2 and you want to show a grouping, you would group them by parentheses. So if you have a situation where you have parentheses around and then another subscript, that simply means whatever in the subscripts or whatever's in the parentheses here is actually multiplied by 2. Okay, so that's important to know. The 2 does not go for the C. So if you want to find any oxygens, you would find oxygen. You would see that there was 3 oxygens, which is multiplied by 2. So you would have 3 times 2, and there would be 6 O's. If you wanted to find the carbon atoms in this big thing, and again, don't get scared with the size of the formula. Just work from your inside out. That's a good advice to use, is working from the inside of the parentheses. So I'm going to go ahead and here I'm going to find carbon. Here it is. Okay. I'm going to see I have 2 carbons. And since this whole thing is multiplied by 2, I'm going to have 2 times 2. So I would have 2 carbons times 2 carbons. But now this whole thing is multiplied by 4, because that's the multiplier for the whole thing. So 2 times 4 is 16. I would have 16 C's. Okay? So that's important to know too on that. All right, if I go to H atoms in this, I would say, okay, here's 4 of them, but watch, I'm getting real sneaky. There's actually a 5th one here. Make sure you don't just go 3 times 4. It's very common for people to say 12 here. Remember, there's 4 plus another one is 5. There's 5 times the 3 in the front would then give us 15H. Okay. And last but not least, if I try out N atoms in this compound, I would find my N. I would see that there's 1 here, right? There's no subscript, so it's 1 times the 3, which is 3. Okay, so we'll say take 3, and then we'll take that. And remember, this whole thing is going to be multiplied by 2. So 3 times 2 would be 6, and we're good. Okay, so what's the summary? Summary is this. All right, we make sure that we know that subscripts go with elements in question. All right, so the subscripts always go with the element in question. Okay, and if you have parentheses, you're going to have to watch for that multiplier. And then coefficients always multiply everything, each element in the compound. All right, so that's a little introduction on how we count atoms and molecules. This is going to be a very important skill that you're going to need to have going forward. So if you have to sit here and practice again with a few more, then practice. Okay, and then let me know if you have trouble. Okay, hope everybody's doing well. Bye-bye.